This is the output display of the E8Flyer. Each particle is represented at a vertice, an 8-dimensional projection onto 2 dimensions. The color, shape, size, and shade are all varying based on the particle configuration. You can manipulate the projection by simply clicking on the locator buttons and dragging to the position that you would like the projection to be. And as you'll see, all of these particles will change to dots, which makes the projection much quicker. And as you drag it around, those dots will move based on the new projection position of that particular dimension. And you can start dragging around dimensions in any position in order to view these projections. Now, in order to get back to the particle representation, you simply have to click the P dots dialog, and that will refresh the screen, which will go back to showing particle symbols rather than the P dots. What you're viewing is a user interface for the E8Flyer. There are quite a few options, so I'll go through these individually and describe each button. The refresh button actually allows you to change multiple parts of this user interface before it actually calculates the new display. That helps in making it faster. Each of the meta favorites is listed in either an or an and column. The or is relating to whether or not the filter process is going to be an or an and process. I'll show that in a bit. The list of these meta favorites is described and shown in a E8 meta favorite video that is up on YouTube. The special one in this column is the none, and that will be basically a 3-dimensional no particles used to add individual particles from the particle selector or the atom selector. Another special one is the in file, which will actually display whatever file has been selected from the in file browse button here. The and column is shown here. The in file browse button here is basically a dialog box to find any data files that you might want to load automatically. This does not require physics-based data. It could actually be any random set of data, columns with headers and rows with particle or vertice names can be used. The out file basically selects whether or not you want to also print to a data file. And if you have a huge set of time steps, that can cause memory problems in the PC. So you can check this and it won't try to save all that into a memory. It'll just dump each individual picture. You can select where you want that file to be located by a directory dialog box and give it a specific name, or this, as you see, is a E8 out with a random number between 0 and 100. You can also select the type of file you want, whether it's GIF, JPEG, PNG, TIFF, or even an AVI if you have a time-stepped animation. In the physics model, there are 3 coordinate lists for binary, E8, and physics. The P-list is a list of pre-selected particle sets. The favorites is a list of projections that provide interesting and symmetrical representations. The number of particles and the number of T-lines is shown after each calculation to count based on your filters and based on which T-lines might be available. The edges are normed to a given length, or you can select all to give you all of the normed edges. It lists the number of each selection here and the total count based on the number of vertices. You can select the color of the edge based on dragging this color slider. These are basically discrete selections for each color band based on the edge length. The P size is a way to manipulate some of the particles. In this case, it's the bosons that you can show in different relative sizes to the other particles. The scale will basically change the entire scale of the whole plot. The frame gives you the X, Y, and Z distance for each scale. The P colors is a slider bar to select which colors you want to assign to the particles. The selector for 0 and 51 are the discrete particle sets that are the most dramatically different based on the Lisi color assignment. Each of these checkboxes allow you to select whether you want to display axes, particles, edges, trialities, the vectors from 0 to the particle location, the labels of the particle, the location of the particle and the projection can be displayed, as well as the mass and lifetime of the particles. This is based on the theory of everything model that I have produced. It's theoretical values, not the experimental values. The perimeter is simply a unit perimeter in either 2 or 3 dimensions that gives you another reference. The P dots was mentioned before. That's the representation of each vertex as a dot. 2D is the default representation. 3D representations can be done simply by selecting this button. In addition, you have some interesting displays for stereo. Anaglyph, that's the blue-green glasses representation of 3D projections. You also have the ability to switch which face of the 3D or 2D model that you are going to be viewing. This is a push-button list selector for which sets of triality rotations you want to include in the triality display. Clear filter simply clears any filter selections that you might have made. This and or will select between the and type model of filtering, which allows only one selection per row, or allows you to select multiple per row. The E8 row is basically selecting which of the rows in the standard model you're going to select, such as the leptons, the quarks, the weak and strong forces, the Higgs, or the 5th row is the excluded or dimensional. The reset path button resets all of their path selections to their default values based on the meta favorite or favorite selection. Time steps allows you to select how many frames of a animation that you're wanting to create. You can select whether the flight through the 8-dimensional space is translational or rotational about a specific point. The point that you want it to translate from or rotate around is defined by whether it's the unidentity or the coordinate of the favorite that is defined below, or from the meta favorite. This is a user interface here that allows you to select the 3 dimensions of a projection and modify each of these selected dimensions by the specific amount. You can either set, which will set the numbers that are selected, or rotate, which will basically take a rotation around at this value, whether it's in degrees, when it's rotational, as you can see, 68.4 degrees, or translational, it is a direct number from 1 to -1, and that rotation will change all the values in the X and Y.